Hello students, today we will do questions of thermochemistry. So we are in the part 3 right now. So to start our today's session. So in today's question session, there will be questions. So we'll start from question number 15 to question number 21 that comprises total of 8 questions. So the instruction for this question series would be that you will be given time to solve this question, that would be 10 seconds. Now it is difficult to solve this question in 10 seconds, so you can just skip some, you can say some steal some time. So while I read out the question, so I will read out the question slowly for you, so that you get the time to solve the question as well and get the question as well in case you have any confusion. So so let us start our today's session. Disclaimer: the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathi@iitcase.ac.in and we shall remove the images. Okay. So first question for today, question number 15. Consider the reaction 4NO2 gaseous plus O2 gaseous gives us 2NO2O5 gaseous. The enthalpy of reaction is minus 111 kilojoule. If N2O5 solid is formed instead of N2O5 gaseous in the above reaction, the delta RH, that is the enthalpy of reaction, will be given. Delta H for sublimation for N2O5 is 54 kilojoule per mole. So your options are A minus 165 kilojoule, B plus 54 kilojoule, C 219 kilojoule, D minus 219 kilojoule. So what is being said in this question is that you are given some data about the formation of N2O5 and you have to find it for the say enthalpy of reaction if this is solid, okay, instead of gaseous. Now what is the hint for this question? The hint for this question that the conversion from gas to solid is given. Okay, means the enthalpy change for that is given, but it is given from solid to gas, not from gas to solid. So just remember this thing. Okay, you don't get this data wrong, or else you will end up solving this question wrongly. So you have 10 seconds to solve this question. Your time starts now. Okay, so your time is up. So let us see how we can solve it. So again, I'm reading out this question and clearing it. So basically, we are forming gaseous N2O5 from its NO2 and O2, right? And in that process, 111 kilojoule of energy is released. Now it is being said that instead of this gaseous, if the solid substance are formed, then what would be the heat of reaction? Means what will be the effect on this heat of reaction? And the data that is given particularly is your 54 kilojoule per mole, which was sublimation, that is conversion of N2O5 from solid to gaseous. Okay, so for those who have solved, the correct answer is A. So this thing is given. Okay, so we have written it. Now what are we doing? We are moving in this way, right? We are moving in this way. So this is the direct approach. In this case, what we are doing is we are moving from here to solid and then we are moving to the gaseous thing. Okay, so just we have splitted the reaction into two halves. Now the theory that is being applied here is very simple. It's your Hess's law. So if you go directly from here to here, or to you go through this pathway, in both the cases your enthalpy change will be similar. So that's the main thing in this question. Okay, so accordingly we will do the things. So this is a sublimation, you don't have to worry about it. So solid to gaseous. Now let us see the solution further. So delta H formation of your solid plus delta H sublimation of solid to gaseous is nothing but your enthalpy of your reaction. Okay, we put this values accordingly. So before that, we have done some arithmetic calculation. We bring this on this side so that we can easily put the values and get the final answer without any hesitation. Okay, so we put these things. So all of this on kilojoule, so we don't have to worry about the units. Unit is very good. Okay, so that gives us minus 165 kilojoule of energy. So during this process, your 165 kilojoule of energy is released if your formed product was solid instead of your gaseous. Now the answer will be minus 165 kilojoule. Correct? Okay. So in this way, you will solve this question number 15. Moving on to the next question. Question number 16. The amount of heat absorbed by 70.09 grams of water for their complete vaporization is, latent heat of vaporization is given 2260 kilojoule per kg. Options are A 23 and 350 joule, 23,352 52 joules, 7,000 joules, 15,813 joules, and 158,200 joule. So what is the main crux behind this question? So first hint I would give that don't miss out this data. Okay, you should know the definition that this is the amount of it that is hidden inside it. So you must supply this much amount to get the conversion rightly, and this thing is given in per kg. Okay, so uh, get the hold of the units also, or else you will make mistakes. So your 10 seconds to solve this question starts now. So your time is up. Now let us see the solution. How can we solve it? So the question was saying that what is the amount of heat that is absorbed on vaporization, means conversion of water liquid into water gaseous, and vaporization of how much amount, 70.09, whereas the latent heat of vaporization is given. So for those who have solved, the correct answer is D. So what is the formula that we will use? So Q is equals to mass into latent heat of vaporization. So this is the hidden heat that you have to provide to convert your given liquid into gaseous. Okay, now we get along with the units. Mass is converted into kg first of all, because this thing is given in the latent heat is already given in kg, so you convert this in kg. Your latent heat of vaporization is given kilojoule per kg. Multiply this thing 0.07 multiplied by 2260. Okay, so that will give you 158.2 kilojoule as your answer. Now further, we have converted this into joule also by multiplying it by 10 to the power 3. That will give you 158,200 joules. So in this way, you will solve this question number 16. Therefore, your correct answer will be D. So again, I am repeating the hint of this question. So the hint of this question is that you must know that your latent heat of vaporization is nothing but the hidden heat that you should supply, or the hidden amount of interaction that is being there in the water, which you have to break down so that it can be converted into your gaseous. And second thing is that unit is very important, right? Because this is given in grams and your latent is for per kg. So convert these things in kg and then you will get your answer correctly. Okay, so this was all. Next, moving on to the next question. Question number 17. Question number 17 says that the enthalpy of formation for ozone, CO2, NH3 and HIR 142.2 kilojoule per mole minus 393.3 kilojoule per mole minus 46.2 kilojoule per mole and plus 25.9 kilojoule per mole. Now the order of their increasing stabilities are, options are A O3, CO2, NH3, HI. Means this is written in the increasing order. This is the least stable, this is the most stable according to this series. Similarly, we have CO2. In B, we have CO2, NH3, HI, and O3. In C, we have ozone, hydrogen, iodine halide. Then we have ammonia, and then carbon dioxide. In D, we have ammonia, iodine hydride, carbon dioxide, and ozone. So you have 10 seconds to solve this question. Your time starts now. Okay. Hope you have tried to solve it. So it's a very easy question. You can easily solve under the given time. Now moving on to the question. Now before that, uh, yeah, moving on to the question. So the question is saying that the formation for all of this are given. Okay. So in this case, you should remember that if the sign is positive, then this much amount of heat is given. Your system's energy is increased by this amount. Similar thing is for this. But when heat is given in negative, that means this much amount of heat is released, or your overall system is been stabilized by this much amount of energy, and same goes for this value. Okay, and now the stability order will be will be determined how it will be determined simply on the basis of energy. Systems having less energy is more stable. For those who are solved, the correct answer is C. Now it is being written here also that energy that means absorbed, means more the energy is absorbed, more the system's stability goes down, because it stays inside the system, or it increases the energy of the system by that much amount. Now if the energy is released, then the system is, or the compound, in this case your whole system is a compound, therefore a compound stability will decrease, because this much amount of heat is released, it is being rejected by the compound, so it is being stabilized by that much amount, and therefore your correct order is O3HINH3CO2. How? Because this is the most negative value that we have, that is 393.3, so it is placed at the last. Okay, just this is the respective one. Then we have for ozone the highest amount of energy release, this is the least stable, so it is in the backward. Then for ammonia, it is being released, so it is written forward, where it is case of this OCO2, it is been given, so it is HI. Clear? Okay, so very easy question. The crux for this question would be that you should remember that we are releasing energy and getting energy. So in case you are releasing energy, you are stabilizing the one. In case you are getting energy, you are destabilizing the one. Okay, so this is for this question. Now moving on to the next question. Question number 18. What is question number 18? Question number 18 is saying that delta H naught of atom B is 134.5 kilocalorie per mole, and delta H naught of atom F is 118.86 kilocalorie per mole. Now you have to find delta HF naught, that is of enthalpy of formation for your BF3. So it is also given. No, it will not find it. It is also given. This is minus 271.75 kilocalorie per mole. Now I have to find the average BF, that means what is the amount of energy, average amount of energy to break the BF bond. Your options are A 97.7 kilocalorie per mole, B 6.6 kilocalorie per mole, then 135.4 kilocalorie per mole, and D 254.3 kilocalorie per mole. So the hint for this question would be that you are given the overall formation of BF3, and delta H naught for B and HF are given. So you will write an thermochemical equation that will involve this boron atom, this fluorine atom, and this BF3. Means simple, the formation from the element itself. Clear? Okay. So your 10 seconds to solve this question starts now. So this much hint is okay. This much hint is good enough to solve this question. So your time starts now. So your time is up. Let us see what is the solution. So first of all, the question was given that the atom B is formed when this much amount of heat is being given. Your atom F is formed when this much amount of heat is given, and your BF3 is formed when this much amount of heat is released, and all are given in kilocalorie per mole. So unit is Good. You have to find the average BF bond, means average bond formation of energy, means average bond energy that is required to break 1 mole of BF bond. Okay. So for those who have solved, the correct answer is D. Let us see how we can solve it. So the dissociation of BF3 can be written in this way. Okay. BF3 gaseous is getting dissociated into B gaseous and 3F gaseous. And that thing is given. Okay. Delta H naught formation is already given, which is 271.75 kilocalorie per mole. So how we'll do it? So delta H naught is equals to 3 into delta H naught of B and delta H naught of B, because one boron is present and as 3 fluorines are present, so we have multiplied with 3. So this is not for fluorine, this is for fluorine, and minus delta H naught formation for the BF3. So this thing is given, this thing is given, and this thing is given. Therefore, we got this delta H naught as 762.83 kilocalorie. But this is what? This is for overall breaking of bond. Means one, not about one bond. This equation is what? First of all, this is about breaking of the 3BF bond, right? And we have written the equation also accordingly. So this is the amount of energy that we have calculated, which is required to break the 3 moles of BF3 bonds, 3 moles of BF bond. But we have to calculate for 1 mole of BF bond. So what we will do? We will simply use this equation, which is 3 into average bond, and therefore your average bond will be division of this by 3. So if you divide it, very simple, 3 to just 6, 3 5 just 15, 3 4 just 12, 3 3 just 9. Okay, so this is approximated to up to 1 decimal places, and that will give you 254.3 kilocalorie per mole as your correct answer. Okay, got it. So what is the clue for this question, or the crux for this question? First, you must be able to write this question, this equation, thermochemical equation, and you must know that the heat or the enthalpy change regarding this equation is nothing but the energy that is required to break 3 bonds of BF. Okay, and accordingly you will find it for 1 bond by dividing it by 3, because average bond has been asked. Okay, average means, so suppose if you are breaking first BF bond, then you will apply less energy as compared to the breaking of second BF bond, because in that case your octet is being distorted totally. Although BF is not completely having a complete octet, but due to the back bonding it is getting much more stabilized. But as you're removing one F, already an electron deficient compound is being debarred from the electrons, and then you're removing the second one, that will require more energy, and the third one require even more energy. But since it has not been specified that for which you have to find, and some data would also be required for that reason the question is asked about the average one. Means you have broken 3 bonds, 3 different energies are there, but you have to find that what is the average energy. So for that thing you simply consider if each BF bond equivalent, and therefore divide it by 3 to get the one, to get your answer, that is 254.3 kilocalorie per mole. Okay, now moving on to the next question. Question number 19. Question number 19 says that in a calorimeter, the temperature of the calorimeter increases by 6.1 Kelvin. The heat capacity of the system is given as 1.23 kilojoule per gram per Kelvin. What is the molar heat of decomposition for ammonium nitrate? Your options are A minus 7.53 kilojoule per mole, B minus 398.1 kilojoule per mole, C minus 16.1 kilojoule per mole, and D minus 602 kilojoule per mole. So what is the main clue for this question? The main clue for this question would be that the temperature of the temperature change is given, right? You have to find the molar heat of decomposition for ammonium nitrate. So you must be able to write the thing which is decomposition. If not, then you can also get through it. So you have to find the molar heat. So what is molar heat? You must know that. And the heat capacity of the system is already given, so you have to subtract that thing. Okay, so you must have to subtract that thing, then and then only we're able to solve this question. So your 10 seconds to solve this question starts now. Let us see how we can solve it. So your temperature difference was given and your heat capacity of the system was given. You have to find that what is the molar heat for decomposition of the ammonium nitrate. Okay, means what is the amount of it that is released per mole. For those who have solved, the correct answer is D. Molecular weight of this say ammonium nitrate is 80. Therefore, heat evolved will be 1.23 into 6.12, because this is given for this much amount is for 6.12 Kelvin, but you have to find it for sorry, this value is for per Kelvin. You have to find it for 6.12 Kelvin. Therefore, you will multiply this thing, right? That will give you your amount of heat evolved for raising the temperature by 6.12 Kelvin. Now the molar heat of decomposition is ms delta T. Okay, so if you put this thing here, so m is the mass, s is given, which is specific heat 6.12, and at is the temperature change. Okay, if you put these things here, you will get minus 602 kilojoule per mole. So this is the amount of heat that is evolved. Okay, you get my point. So basically in this question, it is being given that for for per Kelvin and for per gram, this much kilojoule of heat is required. So you have to find that for this much Kelvin rise and this for 1 mole, that is for 80 grams, how much will be required. So you multiply it by 80 grams to get it for 80 grams, and for required for 6.12 Kelvin, we do the same thing. Okay, and that will give you answer. So very easy thing, just follow the simple unitary method. Okay, that will give you the correct answer. Now moving on further, question number 20. Question number 20 says that the bond dissociation energies of gaseous H2, Cl2 and HCl are 104, 58, 103 kilocalorie respectively. The enthalpy of formation of HCl would be, your options are minus 54 kilocalorie, 54 B 50 44 sorry minus 44 kilocalorie, B 44 kilocalorie, C minus 22 kilocalorie, and D 22 kilocalorie. So the hint of this question would be, so you are given the bond dissociation energy of gaseous atom of all these three. Now you have to find the enthalpy of formation. So you must know one thing, that is what is the thermochemical equation for formation of HCl, and second thing, how can you write the enthalpy of reaction in terms of bond dissociation energy. If you know these two things, you can solve this question. Okay, so your 10 seconds to solve this question starts now. So your time is up. Let us see how we can solve it. Okay, so the question was saying that the bond dissociation energy means to break the bond of 1 mole of H2, 1 mole of Cl2, and 1 mole of HCl is 104, 58 and 103. Now you have to find what is the enthalpy of formation for formation of 1 mole of HCl gas. Now for those who have solved it, the correct answer is C. So this is the equation. I said you to write the formation equation, thermochemical equation for formation. So therefore, this is the way you can write in terms of the bond dissociation energy. Okay, your enthalpy of formation. Now in this case, these are the bonds that are breaking. So that value is given. Okay, no problem. But in this case, your bond that are being formed is given. Okay, in this case, a bond is forming, but this is the value for breaking. So you will take the negative of that. So this is the reason you take the negative. Okay, now just take the summation of the reactant side and the product side. Hence we can write here bond dissociation of H2, bond dissociation of Cl2, add for the reactant one, minus, since we are forming the bond and not dissociating the bond in case of HCl, so minus bond dissociation for HCl. Now we have written all the say terms, and now we are putting the values accordingly against them. So bond dissociation of H2 is given 104, 58 and 103. When you will solve it, you will get minus 22 kilocalorie as your correct answer. Clear? So in this way you will solve this question. So the main crux of this question would be that you should know that how to write your say enthalpy of reaction in terms of bond dissociation, first thing. Second thing, you must be able to write the thermochemical equation for formation wedge shell. So in this whole chapter, you will see one thing common, that if you are well informed about the definition of each of these terms, right, like bond dissociation energy or enthalpy of energy, if you are well informed about each of this, then you can solve these questions easily, because then and then only you are able to write the thermochemical respective thermochemical equations. If you are not knowing what is enthalpy of combustion, you will make mistake. You will take 2 moles of the compound that you are combusting. If you are not thinking about that, you have to take the standard state of the given compound, and you will make mistake there also, right? So that all those things should be in your mind, and then only you will able to solve the question. The calculation is nothing but it's practice, simply practice, but these terms are more important. Anyways, moving further on to next question. So, question number 21. Question number 21 says that given that C gaseous plus 4H gaseous is giving us CH4 gaseous, whereas delta H for this reaction is minus 166 kilojoule. The bond energy of CH will be, your options are A minus 415 kilojoule per mole, minus 41.5 kilojoule per mole, C 832 kilojoule per mole, D none of this. So the hint for this question would be that this is nothing but a formation of 4 CH4 bonds, and you have to find it for 1. Okay, just this much hint is enough for this question. Very easy question. So your 10 seconds to solve this question starts now. Now your time is up. Let us see how we can solve it. So for those who have solved, first we will give the solution, correct answer, and for those who are not solved, we'll get the explanation also. So this was the thing that was given, means the energy changes during the formation of 4 CH4 bonds, 4 CH bonds. We have to find it for 1 bond. Now for those who have solved, the correct answer is B. So very simple, the bond dissociation of CH will be what? Your value that is given divided by 4, because it is given for 4 bonds and you have to find for 1 bond, and that is simply direct question from utility of unitary method, that is division by 4, and that will give you minus 41.5 kilojoule per mole. Okay, clear. Now I would say that one thing that I was already mentioned, that you must know about the thermochemical equation. For that you must know the terms that are there, like bond dissociation energy, bond enthalpy, and everything. Second, you must be able to apply the unitary method very accurately. So that thing is very helpful, and it will help you to solve the question. And third thing is the unit one. Okay, so see, unit is the whole and soul of your physical chemistry, so you should write the unit very correctly. Clear? So this much was for today's session. So with this we end this question session. Thank you.